Right, we still continue our study on concave mirrors. In the previous video, we looked at the relationship between the focal length and the radius of curvature of spherical mirrors. Here we will look at deriving and understanding the mirror formula for concave mirror. One of the most famous or well-known formulas for concave mirrors, which is 1 upon f is equal to 1 upon u plus 1 upon v. In the course of the video, I'll explain to you what is u and what is v, but this is one of the most well-known formulas which is used for spherical mirrors. Here I'm going to look at concave mirror, and within concave mirror also we're going to focus on real image. As you know, in a concave mirror you can have a real image and also a virtual image, right? So here we will look at the case of a real image. So I've drawn this diagram over here. This is a concave mirror. As you can see, there is an object AB. One ray passes parallel to the principal axis and then reflects through focus. There's a ray which passes through the center of curvature, reflects along the same path, and then I have drawn one more line which is incident on the pole, and it goes back in this direction such that these two angles are equal. Now in this we will use a little bit of geometry and try to arrive at this equation. Before that, u represents the distance of the object from P, the pole of the mirror. V represents the distance of the image from P. And yes, we will use the conventions for sign. For example, the convention that we are going to use is, if the direction of this is opposite to the direction of incident ray, then we will assign a negative sign to u, and if it is in the same direction as the direction of the incident ray, then we will assign a positive sign to that. So in this case, pu, this is equal to pb, and what is v? Is equal to pb dash. And so if I start from P and go to B in this direction, the direction of the incident ray is this. This is the direction of the distance pb. Therefore, u will be minus in this case. Similarly, b dash. So pb dash is in this direction, whereas the direction of the incident ray is there. So I'll have minus v in this case. And this is the convention which we'll use for f. Again, it will be minus f and also minus r, because r is again in this direction. R is equal to pc. Alright, so with this convention in mind, let us start. We'll look at two triangles basically and use similarity of triangles. So the first pair of triangles that we're going to use is triangle ABC and triangle A''B''C. So I'm looking at triangle ABC, that is this triangle, and I'm looking at triangle these two triangles. As you can see, these two triangles are similar because they have this angle as 90 degree, which is equal, and as you can see, these two lines are parallel and we have a transversal over here, so these two angles will be equal. Therefore the third angle will be also equal, and therefore they are similar. We'll not spend too much of time here trying to understand why they are similar, but I'm sure you have got some idea about why these two triangles are similar. So if these two triangles are similar, then AB upon A dash B dash, AB upon A dash B dash will be equal to CB upon CB dash. So this is equation 1 we will get over here. Now we'll look at another pair of triangles, triangle ABP and triangle A dash B dash P. So the triangle that I'm referring to over here is triangle ABP. That means I'm referring to this triangle ABP, and the other triangle I'm referring to is this. So the one shown in brown, these are the two triangles I'm referring to. Again, these two triangles are similar because you have 90 degree over here, right angle. These two angles are equal, so third angle will be also be equal, and therefore they are similar. In this case, I'll get AB upon A dash B dash is equal to PB upon PB dash. So this is equation number 2. And from these two equations, I can see that CB upon CB dash is equal to PB upon PB dash. So this is the equation we have got. Now let us look at what is CB. What is CB? What is CB? CB is this, and that I can write as is equal to PB minus PC. CB is PB minus PC. Similarly, what is CB dash? CB dash is equal to, if I look at CB dash, that will equal to PC minus PB dash. CB dash is this, and that will be equal to PC minus PB dash. So if I put those values over here, CB will be PB minus PC upon CB dash is PC minus PB dash is equal to PP upon PB dash. Now what is PB? PB is U, but it is minus U, so I'll write down minus U minus, what is PC? PC is the radius of curvature of the mirror, and that is also R, so minus R upon PC is minus R minus, what is PB dash? PB dash is the distance of the image, that is minus V. PB dash is the distance of the image minus V, so minus of minus V is equal to PB. PB is minus U, and what is PB dash? Minus V. And let me come over here. So what will this happen? This will become minus U plus R upon V minus R is equal to U upon V. And therefore, if I open these brackets, if I do cross multiplication over here, I get minus UV plus VR is equal to UV minus UR. This UV I take on this side, and this UR I take on this side, so I'll get UR plus VR is equal to UV plus UV. So UR plus VR is equal to 2UV. And if I divide this by UVR throughout, so this is UR, so I'll get 1 upon V. This is VR, so if I divide it by UVR, I'll get 1 upon U. And if I divide this by UR, I'll get 2 upon R. And we know that 2F is equal to R. So F is equal to 2 upon R. So this R I can write, therefore I can write this as 1 upon V plus 1 upon U is equal to, for 2R I can write down 2F, so I'll get 1 upon F. So this is how we obtained the mirror formula for concave mirror. What I want you to do is now do the same thing for a virtual image. The diagram, as you know, changes. The image will be behind the mirror, so you'll have the image somewhere over here. Right? The object is on this side, and do the same calculation. Use the same notations and use the same two triangles, pair of triangles, and use the same method. And you will again come back to this particular equation. The only thing that you need to focus on or worry about is the sign convention. Use the sign convention as we discussed in this video, and you will be able to easily arrive at this equation for concave mirror and the case of a virtual image.